2. Last time we were together, we solved systems using the graphing method, but we saw that it's not very accurate. You got to be really exact. Whereas the substitution method and the elimination method, we're going to do both of those today, very exact. You know exactly what the answers are. We're good to go. So, substitution method. What's the root word in substitution? Very good. Substitute. There's a reason they use it. They say it's that method because you are literally going to substitute something for something else. If you are cooking, you do not have an egg, you can substitute. I think it's a half a cup of applesauce for an egg. It has the same. I mean, I've done it before and it does work. So, when I substitute, so I'm going to put in terms of eggs and applesauce. Okay, when I substitute applesauce for my egg, do I have any egg? The egg is gone. I never see the egg. All I see is the applesauce. So when you substitute, you don't see the old thing. You just only see the substitute. Okay, keep that in mind. So what I've got going on here is 2 equations. Again, I still want to know what ordered pair, what XY pair will make both of those true. So what I'm looking for. Well, the use substitution method, we're looking for what I call a clean variable. Clean, what I mean by that is, this x isn't real clean because it's got a 3 hanging on it. This x is not great because he's got a 2 hanging on it. This y is not great because he has a 3 hanging on it. But look at this y bar right here. He's clean as a whistle. He's all by himself. He's free as a breeze. So, I'm going to solve for him, which is why in the first unit we took a long time solving for different variables. They may look kind of goofy, but we got good at doing that. So I'm going to take this equation, and I'm going to put the y by itself, which means I need to take the 3x across the river by subtracting 3x from both sides. So now I have this equation. Y would be my egg, and the negative 3x minus y is my applesauce. Okay? So I'm going to take my applesauce, my negative 3x minus 1, and wherever I see a call for an egg, whenever I see a call for a y in the other equation, I'm going to stick in the applesauce instead. So I'm going to have 2x plus 3, but now I have no egg. I'm going to put in the negative 3x minus 1 equals 18. And the beautiful thing about that is now I just have one variable, so I can figure out what that variable is. So let's just do a little math here. A negative 9x and a negative 3. Don't forget to distribute both of those. I'm thinking that's a negative 7x. And then I'm going to take a 3 across as a positive, equals 21. So x equals negative 3. I'm going to divide both sides. Very tempting, very common mistake is for kids to go, x is negative 3, move on, I'm done. You're not done. You're only halfway done. You found a negative 3 in the answer. You're just halfway there. You got to figure out what's his partner. What is the y value it goes with? Yes, or even easier than that, the best place to put it in is right where you defined who he was going to be. You defined right there where y was going to be. Y is going to be negative 3 times the x, which we now know is negative 3 minus 1. So y is going to be 9 minus 1. So y is going to be 8. Yeah, like that. And if I were to graph those 2 equations, they indeed would intersect at negative 3/8. And if I wanted to check that, what would I do? Into which equation? Both. They have to work in both. I'm not going to check them every time. Tomorrow you're going to have a little quiz though tomorrow where you're going to show me all 3 methods and how to check it. So here's what I mean by checking. I'm going to look at the first 2 equations right here. Okay? I'm going to do 3 times in place of that x, I'm going to put in a negative 3 plus my y, which is 8. It better give me negative 1. Let's see if it does. Negative 9 plus 8. Negative 9 plus 8 is negative 1, so that one checked out. Bingo. But I'm not done because I have to check it in both equations. So in the second equation, I have 2 times my x, which is negative 3, plus 3 times my y, which is 8. Which needs to be 18. It's not, I'm in trouble. So negative 6 plus 3 times 24 is 18. Negative 6 plus 24 is 18. So bingo. So I know without a shadow of a doubt my answer is correct. These are good. Yes. All right, so that's substitution. Now let's go to the elimination method. This is the one you probably remember the most, it's one most people use the most. Again, what is the root word in elimination? And what does eliminate mean, Trina? Yeah, so we want to either get rid of our x's or get rid of our y's, one or the other. And it doesn't matter which one you do. I would find the one that's, if there is one that's easier than the other, then let's get rid of that one. Okay? So, what do you pick? X's or Y's? Well, first let me ask you this. What can I turn the 4 and 6 into? Both of them into. Okay, 24 would work, but 12 would be even better. How about the 5 and 2? 10. Okay? Which do you want? X's or Y's? Okay, I hear Y's? Okay, I hear Y's because one's negative and one's positive already. Whereas if I do these, I'm going to have to do one positive, one negative, which is not a big deal, but. So we're going to multiply this top one. So I want that to be a negative 10. What am I going to multiply by? And don't forget to do it on both sides. And how about the bottom one to get that into a 10? Turn this into a 10? 5 on both sides. So now what I've got is, I'm going to distribute to both, 8x minus 10y equals 6, and 30x plus 10y equals 240. Did that correctly? Beautiful, because now my 10s, I've got a negative 10y and positive 10y. So I have 38x equals 266. I hope 38 goes into that. Does it? 266 divided by 38. So x is 7. Am I done? No. Capital no. So. Yes, plug it back into one of the originals. Here is a hint. You might want, I always suggest using one of the originals because if you use one of your edited ones down here, if you did something wrong down here, then you could be doubling your mistake. You know what I mean? So take it and put it back in one of the original. I'd probably do the first one just because 48 kind of scared me. So I'm going to go 4 times 7 minus 5y equals 13. 5y is, I don't know, what is that, negative 15? So y appears to be positive. Confirmation on that? 7.3. So that's all the examples we're going to do of just doing just the problems. Instead, we're going to jump right into word problems, and I have a worksheet for you. All right, the beauty of these problems is that, think about the unit we're in. We're in systems of equations. The first unit we did was linear. Everything just had pretty much one variable. Well, sometimes I had 2 variables when I do lines and parabolas. But now I have two equations that I'm solving at the same time. So I'm going to be able to use x's and y's in these problems. So kind of keep that in mind of the unit we're in. So here we go. A group of 42 people go to an amusement park. The admission fee for adults is $16. The admission fee for children is $12. The group spent $568 to get into the park. How many adults and how many children were in the group? The best way to do this is to start at the end. If you need to first establish what are my variables going to be. What is the question asking for? How many adults, how many children? So how about we let A be the number of the children that went, And we'll let A be number of children. That's kind of silly. C be number of children. And A be number of adults. And I guarantee you, if you will identify your variables before you start, it really will make your life so much simpler. If you just jump in there and start trying to write equations with just various and sundry x's and y's, it's hard. All right, so let's read the first sentence. A group of 42 people go. Wait a minute. If C is how many children went, A is how many adults went, what can I do with that to come up with 42 total? Add them together. Yeah. A plus C, adults plus children equals 42. That's one of my equations. I call that my quantity equation. It's just how many. I don't know how much money they made. I just know how many people went. But now let's put some quality to it. Let's put money to every one of those. Okay? How much money will each of these adults have to pay? So $16 for every adult, plus how much money every child? $12 for every child. And how much total money will they take in? $568. Now I've got me a nice little system of equations. You can solve it however you want. I'm not going to solve them for you. That will be for you to do. But I can see these here that, elimination, substitution. You could even graph that if you wanted to graph 568. You could go ahead and do it. Yeah. I would. All right, the second one. This is the kind of problem that I guarantee you will see it on every DOC. You will see it on every ACT. Any standardized test, they love, this is like the infamous algebra problem. You've got two variables going in opposite directions, and the speed, and if you ask your parents, they will tell you they remember those questions from algebra. They're very famous problems. So let's get it down. First of all, what's the formula when you're talking about rate and time and distance? What's the formula we use? You know? It's rate times time equal distance. And if you want to use the little pyramid like you do in if it's physics, you can do that too. So if you're looking for time, cover it up and do your distance divided by rate. If you're looking for rate, cover that up and you do distance divided by time. If you're looking for distance, cover that up and it's rate times time. So that way you can get any of it. All right. So I know I'm going to do, since I'm in the systems chapter, I'm going to have two equations. And we've got a vote going downstream and upstream. So how about I'm going to label downstream as one thing. Downstream and upstream. Oh, what am I looking for? I should find the rate of the vote in still water and the rate of the current. Okay. How about let's let B be the rate of the vote. And C be the rate of the current. Alright, do that first. Now for each of these upstream, downstream things, I'm going to have rate times time equals distance. Again, my teaching style comes out. I like things organized. I like little boxes. I like little organization charts. All right, so let's talk about downstream first. A boat travels downstream 16 kilometers. Where would that go? 16 kilometers. What is a kilometer? It's distance, right? 16 kilometers. In 2 hours, where is that 2 going to go? Time. Okay. And returns the same distance. So what does that mean? Yeah. So it's going to be 16 coming back too. Thank you. Not M's. I'm not going to use anything. I'm just going to use 16 because I'll get that mixed up with my A's, C's, and B's. What else do we have? Upstream in 3 hours. Where's that going to go? So, what have we in rate? Okay, let's think about this. If you're going downstream, is that gonna make your speed faster or slower? Faster. So whatever the boat, the rate of the boat would be in still water, plus the rate of the current, make it go faster, right? So this is gonna be the rate of the boat plus the rate of the current going down. Then coming back up though, what happens when you go upstream against current? Slows you down. So what do you think this is gonna be? B minus C. Whatever the boat would normally be going, it's gonna be less whatever the current is pushing against it. It's slowing down that much. All right, so let's take this chart and turn it into two equations. So this times this equal this, this times this equal this. So B plus C times 2, is it okay if I put the 2 in front just so I can distribute it a little better? Equals 16. And 3 times B minus C equals 16. Now I'm going to distribute both of those out. So 2B plus 2C equals 16. And 3B minus 3C equals 16. There we go. There's my system. Solve it however you want. Substitute, eliminate. You do whatever you want. Graph it if you want. But I ain't going to do any of it. I'm going to the next problem. All right. A rectangular room. I'm going to stop right there and tell me everything. The width is 3 less than 2 times the length. What are the dimensions of the room? So the last question, what are the dimensions? What am I looking for? Length and width. So how about let's be logical. I'll let L be the length and W be the width. That's not rocket science. All right. So now, let's start with the first sentence. A rectangular room has a perimeter of 120. How do you find perimeter?
2L.
Careful. It's area, yeah. 2L plus 2W. Okay. So let's start with that. I know that 2L plus 2W will be 120 feet. Just by the formula. It's one of my equations. Oh, okay. So we've got the width. So yes, I'm going to put W. Is, there's your verb. Is or was were. Those are always your equal sign. The width is 3 less than. Am I going to put 3 minus? No. If I say what's 3 less than your age, are you going to do 3 minus 16? No. You're going to do your age minus 3. So if I want 3 less than something, I need to put a negative 3 out here. I'm going to take that away from something. Well, what am I taking it less than 2 times the length? How do I write 2 times the length? Yeah. Bingo. There's your system. And it's already set to not hold around with substitution. Because this baby's already set up for you. Home run. Let's do it. Knock them out of the park. Grand slam even. Now, this was tough. These last 2 are the tougher ones. So please don't be working on the others and totally not catch this. You'll see a lot of these in your future. These kind of problems are called mixture problems. Again, people love to put these on any kind of an algebra kind of assessment you're taking because it's very practical. So we want how many milliliters of a 25% solution must be added to 9 milliliters of a 65% iodine solution to obtain a 55% solution. Sounds hard, and it kind of is until you get the pattern. So I'm going to show you a model. I'm going to show you how you can model it, and then if you keep that in mind, they're really not that hard. Sort of. I'm going to have some liquid at a certain percent, plus another liquid at a certain percent, equals total liquid at a certain percent. So some liquid at a certain percent, plus another liquid at a certain percent, will give me the total of the liquid at a certain percent. And that will work for 99% of these problems. So let's see what we got. How many ooh, that's what they're asking, how many millimeters? I didn't set me up a text yet, did I? So I'm going to let in the milliliters, which means this is liquid, right? It's a milliliters. That's a liquid. Okay, so how many milliliters of a 25% solution must be added? So I'm adding it right here. So I've got in liquid, because I don't know what it is, at 25%, so I'm going to multiply times 0.25. That's that middle one. How much of that must be added to 90 milliliters, that's the amount of liquid, at 65%, in order to get total liquid. Well, wait a minute, total liquid is going to be this liquid plus this liquid. There's no other liquid going to be combined. That's your total liquid right there. The total liquid is 90 plus M, and that total liquid will be at a 55%. So I count these together. Now you need a calculator for sure. You got one while you're right there?
Yeah.
90 times 0.65. What do we got? 58.5. And then you distribute this. 90 times 55. 49.50. Let's just combine what we can. Oh, no, yeah, so we forgot the next huge difference. Give me a minute to pause that so that I give my audience a minute to look at those steps. Okay, last one. Yeah. Peanuts. Peanuts and cashews. Peanuts cost $4 a pound, cashews cost $3 a pound. A 120-pound mixture of peanuts and cashews costs $3.60 per pound. How many pounds of each type of nut are in the mixture? Okay, so the question is how many pounds of each type? So I need two equations, or two equations. So let's let P be the amount of pounds of peanuts, and C be the pounds of cashews. Okay. Yeah, P plus C is going to be a total of what? 120. That's the total. That's the big mama. The final bag. Number of peanuts plus the number of cashews is going to be not the number of the poundage of. It'll be 120 pounds. All right. Then I've got. How many pounds each type of peanut? Okay, so the peanuts will be $4 each, right? $4 there. $3 equals. Be careful. $3.60 per pound. So 132. So yes. $4 per pound peanuts plus $3 per pound cashews, 120 total poundage, $3.60. Again, I'll let you work that out before as part of your homework. And obviously we're not having time for that. So there's your assignment. Have a look. We'll be doing those by elimination or substitution. And then what you haven't finished on the word problems, you finish those as well. And we are having a quiz tomorrow on, I'm gonna give you one problem and have you answer it by, solving it by systems, and by graphing, by elimination, and by substitution, and then checking it in both equations to make sure it works. Real short and sweet. No, it's gonna be real short and sweet.